Welcome back to homework 22, question number 9. We're going to hop over here to the textbook and look at what is the inverse of a function. Well, first we're going to look at an inverse of a function defined by ordered pairs, and that is because in the particular question we're looking at here, question 9, we actually have ordered pairs. You'll see that -4 corresponds to 2, -3 corresponds to 4, -1 corresponds to 1. And then in this example over here in the textbook, we have the same situation. We have ordered pairs. 0 corresponds to 5, 1 corresponds to 6, 2 corresponds to 7, 3 corresponds to 8. And we've represented, or the textbook has represented, this particular set of ordered pairs through what's called a mapping diagram. So in this left oval, what are listed here are the first elements, 0, 1, 2, and 3. This is called the domain. And then over here, the second elements, the range values, 5, 6, 7, and 8 are listed. And then the f function is going to map 0 to 5, 1 to 6, 2 to 7, and 3 to 8. So the f function is right here, 0, 5, 1, 6, 2, 7, 3, 8. The f inverse function, and by the way, f inverse does not, this right here, does not mean 1 over f. Okay, so we want to make sure that we differentiate our notation. The -1 exponent usually does send something down to the denominator, but in the context of inverse notation, this -1 does not mean that. It means going back the other way. If this is Anchorage and this is Seattle, and you have a bunch of flights flying from Anchorage to Seattle, then going back the other way, the round trip, flying back from Seattle to Anchorage, that's going to be your inverse function. It just undoes what you just did. Okay, so instead of adding 5, you're subtracting 5. But in terms of listing out the inverse functions as a set, f inverse as a set is just taking the x and y values and switching them. So right here, notice that in the original function, 3 maps to 8. Well, in the inverse function, 8 maps to 3. So let's go back to my open math. Here, from this table, we can see that if you have x at -3, -3 is going to map to 4. And that's why p of -3 is equal to 4. P inverse of -6 does not mean that you start at -6 in the x column. You actually start at -6 in the y column. Or row, I should say. These are rows, not columns. But you can see that -6 maps backwards from -6 back to 0. And that's why we have a 0 here. So for the graph shows all the points from the table. So you see -4, 2. Here's -4, 2. And then you have -3, 4, -3, 4, etc. What we're supposed to do is plot the 6 points of the inverse function. So to do this, we remember that the inverse just means switching the x and y coordinates. So if the original point was -4, 2, and that's from the original p function, then for the p inverse function, we're going to have the p inverse, let me write a little p inverse here. The point is going to be 2 mapped onto -4. So switch the x's and the y's, and now you're able to go back the other way. So we go to 2, -4. Next point, instead of -3, 4, we are going to plot 4, -3. So 4, -3. This next one, -1, 1, that's this point right here. The inverse of that point is 1, -1. Zero, -6, which is down here, corresponds to -6, 0. 3, negative 2. This is the original point, 3, negative 2. The inverse point would be negative 2, 3. This next point here, 5, negative 7, way down here corresponds to negative 7, 5. Now you might notice, and if you don't notice, I'm pointing it out to you right now, but the line here that goes right through the diagonal so, oh no, where did all the points go? Hold on one second. Aha, there they are. Okay, so what we have here is the line y equals x. All right, so that's your just most basic equation of a graph, y equals x. You will notice that the black points and the red points are mirror images of each other across y equals x. And this is always true of inverse functions. It's like Alice in Wonderland, Alice through the looking glass. The inverse points and the original points are going to be mirror images of each other across y equals x. So that's a good thing to be able to visualize. And so for number 10, this is how we will actually determine whether a function in blue and its supposed inverse in red are in fact a function and inverse pair. So we're going to select the graph which correctly shows a function and its inverse. How will we know? We're going to look at the y equals x equation. So let me draw those in here. If I draw this right here, you ask, is this red line a reflection of the blue line across this green line? Well, no. If that had been a reflection, then we would have expected to see it somewhere along the lines of something like this. Ooh-wee. Okay, this is a little sloppy. But the point is, it would have looked more like this. You see how this red one right here is approximately the reflection of the blue? That's what you're looking for. So this red line here that was given in this problem, that's not going to work. So likewise, you just go through each of these. You imagine a line going right through y equals x. Again, this red one is not a reflection of the blue one. Now we come down here. Ding, ding, ding. Ah, we have a winner. Oh, wait, no, that's still not right. It's supposed to go over here through 2. Not a winner. Let's try this one. Ah, that's much better. Now, part of this got cut off because it looks really steep. This one at first glance looks correct, but I'll tell you how I knew it wasn't correct after I paused. The point here, 0, 2, should correspond to a point over here at 2, 0. Remember, you switch the x and the y coordinates, so 0, 2 must correspond to 2, 0. Also, if this is 1, 4, 1, 4 needs to correspond over here to 4, 1. And you're not seeing that happen for this, but over here you do see that happen. So here you see that we have 2, 0 and 4, 1, just as you would expect. So this one is the correct answer. And the other ones also fail. So here we do not have a mirror image. Here we do not, again, have a mirror image. So now here in question number 11, we're trying to find, this is multiple choice, we're trying to find the graph of the inverse. Here's the original graph. So before we even look at the answer choices, we can see that if we were to draw the line y equals x, then we would expect that our reflection across y equals x would begin, if we match up these points, this is negative 1, 1. So we would have a point over here at 1, negative 1. The x-intercept over here that's just a little past negative 1 corresponds down here to a y-intercept down there. This right here y-intercept, this y-intercept that is going through about 2.2 corresponds to about 2.2 over here on the x-axis. This 1, 3 corresponds to 3, 1. And so you start to see the shape of what the inverse is supposed to look like all the way until it touches over here. And now you can see that what I've just drawn here in red is a mirror image of the original function. So that is going to be the correct inverse. And of course, then, once you know what it's supposed to look like, finding the right answer is quite simple. Okay, so here we are given the original function, and now instead of just identifying the inverse using multiple choice, we are to graph it ourselves. It's a straight segment, so in order to graph a line, you just need 2 points. What's helpful is to remind ourselves of what it looks like to have a mirror image across y equals x, but you can do this without even having to use this guiding line. And the way that you would do it, since you can't draw a line on MyOpenMath, is to identify a couple of the points on the original graph. So for instance, this point right here, this original point is -1, 0. And then let's identify one other such point. This point over here is at 3, -5. So once you just identify 2 of the points on this line segment, then you can take those 2 points and just switch the x and y coordinates of them, and that would be able to tell you where you want to draw your inverse function. So instead of -1, 0, I need to put a point at 0, -1. And instead of 3, -5, I need -5, 3. And now for my inverse segment, here, let me erase this. For the inverse segment, I'm going to be connecting this dot here and this dot here, and then that is going to be my answer. So just identify 2 points on the original one, switch the x and y coordinates, and then that's how you get your graph. And you can see them now together, and you can see that you have a y equals x reflection, a reflection across y equals x. Okay, so that was your c of x, and you need c negative inverse of x. And then the second question, this is a 2-part question, you're going to do the same thing, except now you're starting with g of x, and you need to draw the inverse. So there's 2 distinct problems. One is the function c, the next one is the function g. They're both line segments, which makes it easy to reflect them. So let's walk through the same process again. So step 1, we're going to identify 2 clear points. Ideally, the endpoints would be nice. This one right here is -1, 2. And then this one over here is 4, -3. So for the inverse, I want to switch the x and y. Instead of -1, 2, I need 2, -1, which is down here. And instead of 4, -3, I need -3, 4, which is up here. And then I am going to connect those 2. And as it so happens, there's considerable overlay here. But that's because the line is going exactly through, it has a slope of -1, and that would make it perpendicular to the +1 slope, and if you have a mirror image across a perpendicular, then you would expect something like this. Alright, so here would be the answer. As you can see, there is overlap. All right, so now this is a whole line. We're given the original graph, and we need to do the inverse. In this case, we're going to do the exact same process again. We're going to identify two of the points. So for instance, this point is 3, 0. Pick some clear ones. And then this one right here is 0, -2. So for the inverse, I want to switch the x and y. And plot one of the points at 0, 3. And the other point at -2, 0. And now connect these. This is an entire line, so when you graph this on My Open Math, it will continue on graphing it so that you'll end up with a whole straight line. That's supposed to be straight. My Open Math will graph it as a straight line once you just give it 2 points. Okay, so here we are given a table for G. We're supposed to plot the points. That's rather straightforward. You just plot all those points on the XY coordinate system. And then it says, what is the formula for G of X? So then you come up with an equation of the line through the points. And that's something that we've done before. And you should have done something like this in Algebra 1. Just to give you an idea of what it would look like, though, you're going to take each of these points when you plot them, for instance, -4, 7, -2, 4. You'll end up with a bunch of points, and then as you plot all of these points, you'll see that they are following a particular slope. You're going down 3 over 2, down 3 over 2, down 3 over 2, down 3 over 2 again. And that's how we're getting the slope of -1.5. That's the slope of -3/2, which means down 3 over 2. And then the +1 is the y-intercept, and we get the +1 y-intercept from the fact that right here you can see that the intercept is +1. So that's how we get the equation right there. Now once you've done that, you're going to take the same table again, and this time plot the inverse. Alright, so when you get to this part of the problem and you need to graph 6 points for the inverse, I'm going to put this in red, the inverse is going to be to take each of these points, and instead of x, y, you need to graph the inverse points as y, x. So as I go through each of these points, I'm going to go the opposite direction. Instead of -4, 7, I'm going to graph 7, -4. So I have 7, -4, 4, -2, 1, 0, -2, 2, -5, 4, and -8, 6. And you see that you're starting to form then a line that does not have a clear y-intercept. So how do we get the equation of the line through points? This goes back to our Algebra 1 skills. We can at least see, just by looking at the diagram, that our line goes down 2 over 3. Down 2 over 3. So the slope of the line is -2/3. So then we want to plug in the slope into the point slope form that we learned in Algebra 1, and we reviewed this earlier in this course. And then you can pick any point you want. For instance, if you want to use this middle point, instead of 0, 1, remember that this point is going to be 1, 0. So you plug in the point and you plug in the slope, and then you use the distributive property, and after you plug in -2/3 for m, 0 for y sub 1 and 1 for x sub 1, and use the distributive property, we end up with y is equal to negative 2/3 x plus 2/3. Now this equation is actually the same thing as g inverse of x. You can see though at the bottom of the screen here that the equation that is presented here looks nothing like this one. So where on earth would they get an equation like this? They would get this equation by using a different technique than what we just used. The technique we just used was to plot the points and then find the slope and take a point and then use the point slope form, basically using the old technique from Algebra 1 that is worthwhile to review. They're using a technique that I have not taught you yet, and that technique I'm about to teach you. And so if you do want to end up using that technique here, you can. But I do think that this would be the best thing for you to do because this is a review from earlier on in the course. This is a fundamental skill of Algebra 1 and Algebra 2 to be able to take points and to write a linear equation of a line going through points just based off those points. And so that's why I recommend that you approach the problem this way. All right, we're going to pick up with the rest of this lecture in the third video.